In this section, we'll take a deeper dive into runtime mechanics. In this module, we will look at atom behavior, some advanced runtime options. We'll look at molecule and cluster techniques, and we'll consider low latency and atom workers as well. The goal of this module is to enable you to select the appropriate runtime architecture for an organization based upon functional and non-functional requirements, and then communicate the important architectural considerations for different use cases. So why is this important? Well, it's important to be able to properly maintain your runtime architecture. It's important for you to consider also what kind of impacts this will have on performance and success of your integrations. You want to maximize the value that you get out of AtomSphere and minimize the runtime problems and support issues that you might face. So before we get into our first topic, let's review some basic concepts and definitions. A JVM is the Java Virtual Machine. It is a single operating system process running on the Java platform. A cluster is one or more JVMs that work together as a logical molecule or cloud. A node is a single molecule or cloud JVM running as part of a cluster. So a cluster is comprised of multiple nodes. An atom is a single tenant, meaning single account, single node AtomSphere runtime engine. The molecule is a single tenant, multi-node AtomSphere runtime engine. A cloud is a multi-tenant, multi-node AtomSphere runtime engine. So it can support multiple accounts, multiple customers on multiple nodes, and it scales for availability. Hard disk or storage is the persistent long-term data storage available on the computer or server. Heap is the transient working memory for a JVM. This is a subset of memory that is owned and managed by a Java process. Essentially, it is carved out of the available RAM memory on the machine. A thread is an executing code path within a JVM. Each JVM will have multiple threads running concurrently. Let's review some Atom basics. We know from Architecture 1 course about the Atom installation and some of the directories. The bin directory contains option files for adjusting runtime values. This is also where the executable exists for you to start, stop, and restart the Atom as well. The connector directory contains the Java libraries associated with the processes you have deployed. The execution directory contains metadata for the processes that are deployed to that Atom. It's important to note that we will cover this again later, but there is only one set of folders for a molecule on the shared storage for the molecule or Atom cloud. Here are some more directories that we couldn't fit into the previous slide screenshot, but are worthy of mention as well. The data directory houses every file or document that comes into your process on this Atom. How long that data is stored in the data directory is configurable through the user interface. The counter directory is for the trading partner shape with the counter parameter. The state data for those shapes is stored in the counter directory. The logs directory contains container logs for each JVM in the Atom or cluster and other logs as well. The user lib directory is important for custom configuration. This is where you install the custom database driver if you need to integrate with a custom database. The message directory stores data that is being sent back and forth from the platform. The queue directory relates to Atom queuing. The .cache directory is a temporary directory for the document cache shape. The temp directory is used during execution if needed to keep under the allocated heap space. Once again, for a molecule or a cloud, these directories are shared. For an Atom cloud, the user lib folder is shared, or user lib can be per account. This way, if one customer needs a custom database driver, they can keep their user lib folder distinct. Now looking at communication between a local runtime and the platform. As I mentioned earlier, all communication is initiated from the runtime to the platform through HTTPS on port 443. In each molecule cluster, one node will be considered the head node. The head node is responsible for communicating with the platform for pending instructions and picking which node to handle the next execution, while the other nodes do communicate metadata about executions to the platform separately as well. So the local runtime is constantly checking for updates, several times a minute. They serve as keep alives for the platform. If enough of these heartbeats are disrupted for long enough, the platform will consider the runtime to be down and mark it as offline. So what exactly is the runtime checking for? It is looking for configuration changes either to the runtime or a process. Remember that some changes to the runtime are managed in the user interface, so it will get those changes that occur there. Schedule changes and execution requests are also monitored. And if you deploy or redeploy a process and edit extensions, this is picked up. The Atom also uploads process metadata. This is count and size of documents. This is not uploading the data, only the execution statistics. And lastly, the runtime is also checking for document view requests. These requests are redirected to the local Atom. The document is not persisted on the platform. So what happens when the communication breaks down? Well, you can imagine it is not able to get all the changes from the platform that I just listed. So process reporting won't have the latest process metadata. Scheduled changes or updates will not be communicated. However, scheduled processes will continue to execute. Deployments will not propagate. And it creates a retry loop error in the Atom logs. When the communication is reestablished, the log and metadata will be sent to process reporting for the scheduled processes that did not run during the outage. The platform also sends out an Atom down notification. This will generate an event log which you can use as an alert via email or RSS feed. It's good to note that upon failure or outage, the duration between attempts to communicate also slows down. The config settings in the runtime installation can be customized through the Atomsphere UI. These are only available for a local runtime and not a cloud runtime. Through the UI, you can set basic and advanced properties and view the Atom configuration. The Java level changes must be made through the files, not the UI. The VM options and pref_jre files control the configuration of the Java machine itself. A common thing to change here is the heap allocation for the runtime. The pref_jre controls the Java version of the runtime.